Taking a look at why sine of theta is equivalent to cos of 90 minus theta. So to understand this, I'm going to go back to the right angle triangle and go back to what the trig ratios are. So first, let's take a look at sine of theta. And if I follow the angle theta, it's the green angle there. So the green angle, sine of that, well remember SOHCAHTOA, sine is equal to opposite, which is going to be x, all over hypotenuse, which is across from the right angle, which is z. So that's what sine of theta is equal to. The next thing that I want to focus on is that 90 minus theta and what that might refer to. Well, if we look at this other angle up here, which is the angle beta, just giving them random letters, you don't need to use those letters. I'm just using them to keep track of different angles and sides. So beta, well, if I wanted to find that missing angle, what I would say is that it's part of a triangle. All the angles in a triangle add up to 180, and I'm going to take away the two angles that I supposedly know. So I supposedly do know what theta is, so take away theta, and take away the right angle, so take away 90. If I then sort that out and I reduce it down and tidy it up, I'm going to have that beta is equal to, well, 180 take away 90 is going to be 90, and then I still have take away theta. So the reference up here to 90 minus theta, what that actually means is the angle beta up the top here. And hopefully you can see why. If I wanted to find that angle beta up here, I've just talked you through how I would do that. It's equivalent to 90 minus theta. So actually, I could say that this is cos of beta is what I'm looking to talk about. Because beta is equivalent to 90 minus theta. And if I want to do that, cos of the angle, if I think back to SOHCAHTOA, cos stands for adjacent over hypotenuse. So the adjacent to the angle beta is the one that's next to the angle beta. In this case, it's x all over hypotenuse, while the hypotenuse is the same. What do you notice? Well, I notice that these two, the two ratios themselves, are equal. X over z and x over z, which tells me that sine of theta, which is equal to x over z, must be equal to cos of beta, which is also equal to x over z. So this is what I have. And if you remember back, I said that beta was equal to 90 minus theta. So what we're going to have then is that sine of theta, if we take out the middle part, is equivalent to cos of 90 minus theta. That's it. There's your complementary angles. That's all you need to know, and you will be expected to apply that in different scenarios, so it is important that you do understand it.